Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at not only calculating stationary points, but determining whether they are a maximum or a minimum stationary point. So let's look at this function here. We'll start by calculating its stationary points. Remember, we learned in a previous video, the stationary points occur when the derivative is equal to 0. So the derivative of this function, again going term by term, is just x squared plus 2x minus 8. So the stationary points occur when the derivative is equal to 0. Because remember, the derivative is the gradient, and the stationary points are precisely the points where the gradient is 0, when the function is neither increasing nor decreasing. So if in this case the derivative equals 0, we have x squared plus 2x minus 8 equals 0. So this one's an easy one to factorize. Two numbers that multiply to minus 8 and add to 2 are x minus 4 and x minus 2. So the possible stationary points occur solving this equation. If x plus 4 equals 0, we get x equals minus 4. If x minus 2 equals 0, then x equals positive 2. So these are the x values of the stationary point. To find the y value of the stationary point, we just substitute them back into the original equation. So if x equals minus 4, substituting that in, we get y is 27 2/3, and substituting x equals 2 into this original equation, we get y equals minus 8 2/3. So the two stationary points are minus 4, 27 2/3, as well as 2 and minus 8 2/3. So we've calculated the stationary points. Thing is, we don't know whether they're a maximum or a minimum. So what we've figured out is there's a stationary point at x equals minus 4 and one at x equals 2. So what could happen is the curve could go like this at x equals minus 4, or it could go like this. We don't know which one. Similarly, at 2, it could be like this, or it could be like this. We just don't know. So we need to determine which of those it is. If it's like this, we call this a maximum turning point or maximum stationary point because it reaches a peak. It goes up, reaches a peak, and then turns around. So it reaches a maximum y value. And if we have one that looks like this, then that's a minimum stationary point because it goes down, reaches a minimum, turns around, and comes back up. It's important that we note that these are only local maximum and minimum. It doesn't mean it's the maximum or the minimum of the entire function. Because what you could have a function that goes like this. Well, this turning point here is a maximum turning point, but it's certainly not the maximum of the whole function because there's higher values over here. Similarly, this would be a minimum turning point, but it's not a minimum of the whole function because there are lower values over here. But this is the minimum value, the minimum y value, sort of in this neighborhood. That's why we call it a local minimum. This is a local minimum, and this is a local maximum. So we found the turning point. How do we determine whether or not it's a maximum or a minimum? So this is how we're going to test whether a stationary point is a maximum or minimum. We use the first derivative test. We set up a table like this or like this. So what we do is we put the stationary point in the middle and we test values of x either side of the stationary point. One that's a little less than the stationary point, one that's a little more. At each of these points, we see, is the gradient, which is the derivative, negative or positive? So remember, if the gradient's negative, then the graph leans to the left. Stationary, it's horizontal, and positive, it leans to the right. So if you get a situation like this, we can tell that this is a minimum because the function's coming down, hits the minimum, and then goes up. So this is what we would get if there was a minimum stationary point, and here what we would have is the opposite. The what we're saying here is the point just before the stationary point, the gradient is positive there, so it leans to the right, horizontal at the stationary point, and then the gradient's negative afterwards, so it leans to the left, and that would be a maximum turning point. So let's go back to our example here. We know that we have stationary points at x equals -4 and 2. So we're going to set up our table and we're going to test these points. So we want to test x equals -4 and x equals 2. We want values either side. So I'm going to pick a value of x just less than -4 and one that's just more than -4. So for 2, I've got an x value that's less than 2. Now I'm going to pick one that's a little more than 2. So let's calculate the gradient at each of these points. To calculate the gradient, I just sub the value into this gradient function here. So if x equals -5 and I substitute that into here, I actually get 25 minus 10 minus 8. I get a positive value. So if I were to substitute -4 here, I know I'd get 0 because it's a stationary point. If I substitute x equals -3 here, I get 9 minus 6 minus 8. I get a negative value. Substituting x equals 2 into this equation, I would get 0. Substituting x equals 3, I would get a positive value. So what does this all mean? So this means just before this stationary point x is -4, the gradient's positive, so the curve is leaning to the right. At the stationary point, we know it's horizontal. Just after this first stationary point, we see here that the gradient's negative, so the curve is going to lean to the left. So it's going to lean down there. So what we can see here is that this point here is a maximum stationary point, because what's happening is before it gets to that point, it's increasing, reaches its peak, and then goes down afterwards. So the opposite is true at x equals 2. So before x equals 2, the gradient's negative, so it's coming down, it's decreasing. Then it's horizontal at x equals 2, and then it's positive after x equals 2, which means the curve is leaning to the right. So at x equals 2, it's decreasing until it gets to x equals 2, horizontal, and then it turns around and increases. So that's how we know that this is a minimum turning point. So first, just calculate the derivative, then find when that equals 0. That tells you the stationary points. And then use this first derivative test to determine whether it's a minimum or maximum turning point. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.